Awesome. Okay. We're learning something brand new. I ask all of you to know that this is brand new. So how about we don't get behind and we start paying attention right off the bat? And that great video said something about z-scores. I will give you notes in a minute. But for now, I just want to talk about a few things. All right. So the football team lifts weights in the morning. They lift weights in the morning. And the mean, you don't need to write any of this down, of weight that they can do in the bench press, that's when they're laying down, is pushing up and down, is 200. It's our football team. It's 150. Okay, it's 150 pounds that they can lift. Okay, that's the average. If you take all the people on the football team that go and they lift weights, the average score would be 150. The standard deviation, I'm going to explain this now. The standard deviation is going to be 30 pounds, and that's going to be a relatively small number, and I'm going to show you what it means. Okay. Do all of the people on the football team that lift weights, probably if they do it a lot, they get pretty good at it, okay? If they do it a lot. Not all of them, and some get a little better than that, okay? All right, so here's the football team. Well, in this class, we also, if we would all do weightlifting, because we got some people that can just lift a ton of weight, okay? I mean, like Evelyn Fox, I imagine you'd go in there and just like pretty much lift the whole thing, you know. Aiden, I'm not sure you'd get any, I mean, they do, okay. But now here, in this class, I'm going to say that the standard deviation is 60. And here's what I'm trying to get across to you. On the football team, would most of the amount they lift be closer together than in this class? Because in this class, some of you don't care at all about weightlifting, or maybe you're a smaller person, and maybe some of you are not on the football team, but you're really good at lifting weights. So the bigger standard deviation means that the numbers are going to be more spread apart. Some heads shaking that seems to make sense. Okay, in this class, your average score might be maybe an 85% with a standard deviation of 4. And I'm going to compare that to a random old 7th grade class when I used to teach 7th grade. Try not to think back to those days because we might be very sad thinking about 7th grade. But also it might be 85%. But the standard deviation might be more like 9. This class right here, all of you have chosen to be in this class, or your parents made you. How many did your parents make you? Okay. So you've either chosen, or a couple of you, your parents might have made you. So you've chosen to be here. So you have chosen to probably try at math, or you're good at math. So probably your scores are going to be closer together. As opposed to, remember back to just regular old random 7th grade class. In 7th grade, were some of you do tremendously well in 7th grade, but also were there just the whole bunch that did almost nothing and didn't try? See, in this class, we don't have many people not trying, not doing much. Okay, most everyone's giving a good effort. Whereas a 7th grade math, you're going to have some people doing great, but also a lot of people doing poorly. All right? So does that make sense that makes that standard deviation head shaking? Bigger standard deviation, you've got more high, more low, and things are sort of spread out. Whereas in this class, because all of you have passed Algebra 2, all of you chose another class, it's more, your grades are more close. There's less kids doing amazingly well and less kids doing just very poor. Okay. All right. So on that video, even though you couldn't hear it all, Mr. Malky goes to LA Fitness up there in Oakdale because at LA Fitness everyone has tans because it's Los Angeles and they're like Southern California vibe. So he goes there. And he saw this guy that was lifting a lot of weight. All right, those of you that are paying no attention to me, please don't ever ask me questions on how to do it because you're not paying attention. All right, at LA Fitness, he went and he asked the boss, hey, have you figured out what the average weight is that people can lift, the mean? And they said it was 150 pounds. All right, so this was the average. And the standard deviation was 60. Because there are quite a few people that go to the gym that can lift a lot more than that. And there's some people at the gym that are beginners. All right, cool. Well, Mrs. Bach saw a really fat cat. A really fat cat. Now, I don't know much about cats, but I was told that an average cat weight 10 pounds, is that head shake, or is that too much, or should it be 8? What should I say, 10 or 8? 8. Average weight is 8 with a standard deviation of 3 pounds. And by the way, just so you know how they say, if your cat gets all wet, don't put it in the microwave to dry it. They're right. And me, I was down there on Lake Road, and I could not believe what I saw. The cops told me that the average speed is 42 miles per hour. Is 42 miles per hour. And the standard deviation is 5. So now here's the deal. Mr. Malicki, Ms. Bach, and myself were arguing on whether he saw somebody that person that was lifting weight was amazing. She saw a really fat cat. That was more amazing. I saw somebody driving real fast. Well, here's the difference. Okay, here's the difference. When Lucy and our gymnastics people in here, when they're doing gymnastics, the judge judges you doing the vault, and then the next person doing the vault, and then the other team doing the vault, and let's assume it's a good, honest judge. It's pretty easy for them to judge. You did a better vault, you got a number, you got a vault. Head shaking, that's pretty easy that's pretty easy in that. Do I have, I used to have the other Gabby who did diving. Any of you do diving? All right. Assuming they're good judges and they're fair judges, is it easy for a judge to judge diving? They judge this diver, now the next one goes, now the next one goes, and they can judge the diving. Head shaking, that makes sense. But now, we got into an argument. We're trying to do the following. Mr. Malicki saw somebody that was lifting 270 pounds. And he goes, wow, that was amazing. Mrs. Bach saw a cat that was 13 pounds. And I saw somebody who was driving 52 miles per hour. So now we got in an argument as to which was more remarkable. Is it more remarkable this person was lifting 270 pounds? Or was this more remarkable that she saw a 13-pound cat? Or was it more remarkable that I saw somebody driving 52 miles an hour? All of a sudden, we're trying to compare 3 clearly different things and see which is more amazing. Well, there's a way mathematically to do this, and it's called z-scores. And I'll move the screen over there in a minute. But what z-scores will do eventually, this is just the first easy day, will give us the percentile of where they rank, where this person ranks on weightlifters. Are they truly remarkable in this world of weightlifting? Or is this cat truly remarkable on being a big cat? Or is this driver being truly remarkable? So what this z-scores will do, and this is just our first day, we have 3 days, will help us compare which of those was more amazing things. So over here, you in class have seen this already. All right, the z-score formula. And I am not pleased. I'm pleased. Well, let me be positive. I'm very pleased with most of you giving this good effort today. I'm very pleased with most of you. All right, the z-score formula for today, and it will get much more specific as the following. The data value, that's a U-V-A-L-U-E, not valve. The data value minus the mean divided by the standard deviation. And that gives us the z-score. Today, those of us watching at home, this is just the first day for today. The larger the z-score, the more quote-unquote remarkable whatever we are talking about is. So now mathematically, we are going to calculate which of the following was more remarkable. So with Mr. Malky, seeing this person lift a lot of weight, the z-score equals that person over there lifted 270 pounds. The mean of what weight people could lift was 150 pounds. The standard deviation is 60 pounds. Would you all do that brief calculation? If you got two, say I got two. Cool. For today, we will be going much more specific on day 2 and day 3, but this is only day 1. All right, the z-score for Mrs. Bach and the cat she saw. She saw a 13-pound cat minus the mean, which was 8. The standard deviation is 3. Please do that brief calculation. Is it about 1.7? All right. And finally, I saw that person driving really fast on Lake Road. In fact, they were driving at 52 miles an hour. The mean is 42. And over a standard deviation of 5. And just as it randomly would be, the bigger the z-score, the more remarkable. The person lifting weight and the person driving were equally remarkable. That cat was less remarkable. Like, wow, that was pretty impressive. But these were like equal, neither was more. And that's what the z-scores are to start. We will get much more specific on percentiles, weighted average. We'll get much more. But on day 1, that's day 1. I think on Schoology is a short, brief assignment on this, and we are on our way to our newest topic in our mathematics.